Hello everyone, and welcome to TechnoBoss. I am MacGyver, and today we, to include me, are going to be learning some basic programming and circuitry based on the Arduino platform. The kit that I'm using is the Artist DIY kit that I found on Amazon for $83. Take note, none of this is sponsored by anybody. Okay, I wanted to learn some of this stuff, and this kit looked like it might actually fit the bill. Lesson 4, Controlling Relay. Overview. In this lesson, we will learn how to control a relay to cut off or connect a circuit. Requirements. An Arduino Mega 2560 USB cable, an NPN transistor, the S8050, a 1K resistor, a N1 4001 diode, a 220 ohm resistor, a relay, an LED, breadboard, and about 7 jumper wires. Principle of a relay. A relay is an electronically operated switch. It is generally used in automatic control circuits. Actually, it is an automatic switch, which uses low current to control high current. It plays the role of an automatic regulation, security protection, and circuit switch. When an electric current is passed through the coil, it generates a magnetic field that activates an armature. The consequent movement of the armature either makes or breaks, depending upon construction, a connection with a fixed contact. When the current to the coil is switched off, the armature is returned by a force approximately half as strong as the magnetic force to its relaxed position. So in this little diagram, we've got this coil, the normally open contact, the common contact, or the normally closed contact. And this is the little armatures that they're talking about. When this coil generates a magnetic field, it moves it from over here to over here. If the set of contacts was closed when the relay was de-energized, then the movement opens the contacts, breaking the connection, and vice versa if the contacts were open. Usually this force is provided by a spring, but gravity is also used commonly in industrial motor starters. Most relays are manufactured to operate quickly. In a low voltage application, this reduces noise. In a high voltage or current application, this reduces arcing. When the coil is energized with direct current, a diode is often placed across the coil to dissipate the energy from the collapsing magnetic field at deactivation, which would otherwise generate a voltage spike dangerous to semiconductor circuit components. And speaking of diode, a diode is a semiconductor device that essentially acts as a one-way switch for current. It allows current to flow easily in one direction, but severely restricts current from flowing in the opposite direction. So it's a little bit like a check valve for like a hose or hydraulics or pneumatics. Okay, and like an LED, we got the anode and the cathode. So this is the positive. The anode is the positive. The cathode is the negative. Procedures: build the circuit. Okay, in this diagram we got a 6-pole relay. I got a modified 5-pole. We'll go over that a little bit later, but we're basically going to be building the exact same thing here. Okay, program. I got a feeling we're using the exact same program as with lesson 1, and we're just going to replace LED pin with relay pin. We're going to compile the program, and we're going to get another blinking LED. Pretty simple. So the whole purpose of this is to walk us through the steps from a microcontroller to a transistor to a relay and then to bigger, so that then eventually we can start to control something like the power to an entire house or larger using nothing but a little tiny microcontroller. So let's get building the circuit. Here we have all of our components. We have our Arduino. USB cable is off screen. We have our transistor. We have our 1K resistor. We have our diode, our 220 ohm resistor, our relay. I actually modified, this is a 5-pin relay, and I modified it with a 5-pin header. I'll be putting out another video to show how I did that. Have the LED, the breadboard, and of course our jumper wires. So let's start getting this thing put together. So let's go and start with the transistor. And we're going to put it somewhere over here. Just kind of wiggle it, wiggle it, wiggle it. Come on. I don't like how it doesn't like to go in. Oh, wait, there we go. And it's in. Okay. Our 1K resistor. Ooh, you know what? I'm going to move this to this side. Otherwise, we might be running into some problems. So I'll just move it all the way over. Oh, and this thing, just come on. There we go. Nice and easy. So now the 1K resistor. So now it needs to be in line with the center pin. That's part of the reason why I decided to move it. Oh, hey. Ooh, I'm getting better at this. Got it in without using the pliers. Okay. So now comes the relay. And I have myself here a little cheat sheet so I know which wire is hooked up to what on the relay. And I'm going to take this and I'm actually going to place it right here. Come on, come on. There it goes. Okay, then the 220 resistor, it looks like it's coming from the normally open, so the green wire, and we're just going to have it come here across the board. This has to go to somewhere. So now we take our LED, the anode, and then the cathode. The anode is longer. Okay? So our flow of current is coming from this side to this side. So our LED is going to go right there. So we got the anode up here and the cathode down here. Then we have our diode. You got this little band. This side's the cathode because that's where the band is. And this is the anode. And this needs to go across the coil, which is the red, which is the white and the black. So let's go ahead and put some turns into this. I sure hope I did that explanation on screen. And let's see here. We're going to want the current. Come on. There we go. There we go. That's right. And the reason why I want it like this, to where the current's flowing from the white to black, is because we're pushing in current through the black wire. And if the white's the return, the white's actually going to come over here to the transistor. And to make sure we don't overload this transistor, it needs an escape route. So when power is cut off to the black, it can then dump in a nice little, it's almost like a little short circuit that it can dump in to dissipate the built up power. Okay, so all the components are on the board. Time to wire up. So we need our hot, 5-volt hot. Let's see here, in, ground, 5-volt, and bring it over to the board, to the hot. Okay. Actually, no. Incorrect. It's wanting us. Yeah, we're just going to bring it to the hot. If I have to grab another wire, I will. Okay. And then the ground, we're going to use these pins over here again and ground out. Okay, so we got our hot and our ground going to the board. So we're going to run a wire from here. Now, with this board, only half of this is actually connected, not the other half. So if I go to here, I'm still within the connection. Okay. Then our yellow, they want us to use pin 8, which is this one right here. And this is going to be going to activate the transistor. Okay. Then we're going to grab our nice little purple wire here. And it is going to go from the one leg of the transistor to the ground. Okay. We've got our blue wire. We're going to need to power, let's see. Actually, we're not going to worry about powering the relay yet. This is going to go to controlling the relay. So then that is going to go right there. So we will need to grab one more wire, and that is okay. So that is hooked up to the black. And we're going to hook that into a hot. Come on. There we go. Actually, no. I think I can definitely do this to where so I'm going to pull the green, have the orange just pop over one to the black, move the red there. So what's going through the red is going to go to this row. This orange wire is going to draw off of this to feed the red. The black is going to be fed through it. And then we have our green. There we go, it's in. And it is going to go to ground. Alrighty. So, either I have screwed up royally and something's going to fry, or, just maybe, this is going to work. Hopefully this works better than the last time. I guess we shall find out. Alrighty, let's get this code knocked out. So, wrong page. So we know it's going to be pretty much the same code as lesson 1. So, instead of LED pin, we're going to say relay. Helps if I spell it correctly. And equals 8. We're going to say time equals 1000. And that should be it for our global variables. let's see here, pin mode. Relay. Wait, caps lock. Output. I am pressing all sorts of wrong keys. Then the loop. Digital right. Relay. Hey, he spelled it right. High. Oh, sheesh, and I forgot the same thing again. Semicolons. Semicolon, semicolon, semicolon. Delay. Time. Delay. Digital. Right. Relay. Low. I have no idea what it is. There we go. Nope. There. Delay. Time. Semicolon. And there we go. So let's get this USB cord plugged in. Please no blue smoke. Okay. Check the code. Oh, wait, error. Wait, it didn't do an error? And we're just going to compile and check again. Okay, good, no error. Load. Oh. And it's working. So, we got this done. So we're using the board to control this little guy, which is controlling this, which is used to control this. But this can be used to control something a lot higher current. That is it for this lesson. I encourage everyone to experiment with the code to see what you can do. If you found this video helpful, please like and subscribe and ring the bell notification to be notified when new videos come out. Until next time, good luck, have fun, and stay curious.